Hello and welcome to another episode of the CG Garage. This is episode number 474 with Junaid Baig, who is the head of applied technology over at DNEG. A really fascinating person. I got the chance to hang out with Junaid last year when we were talking about stuff in virtual production and sort of asking questions about his thoughts on Project Arena, which wasn't even called Project Arena at the time. And he's been a fascinating person to talk to, really knowledgeable, which is one of the reasons we like talking to him. And we get to learn about his past. Yes, while most of us were, back in the day, playing with Barbies or G.I. Joes or BMX bikes, he actually had the chance at a very, very young age to learn 3D Studio. And that's what he was goofing around with as a kid. And he's then turned that into this incredible career that he has, literally from a little kid all the way till now, which is kind of cool. Led to some incredible VFX projects he's worked on over the years. He's been working in pipeline for a long time, and lighting pipeline specifically. So he knows a lot about lighting. And we talk a lot about that too, which is really cool. And of course, head of applied technology, he talks a little bit about what that group does and what he's doing there, and what he's doing specifically in virtual production, which is kind of cool as well. And why, his thoughts on Project Arena and how that fits into virtual production, especially in camera VFX. So really great to have Junaid on to give us his perspective on all that, which is really, really cool. Okay. In terms of announcements, just go to chaos.com for this. And speaking of Project Arena, if you guys are interested in knowing more about Project Arena, or you want to sign up for it, in terms of you have to have a VFX or a virtual production stage for this to really work. But just go to chaos.com/virtual production. Again, chaos.com/virtual production. We have some information on there as well. And in terms of events, just go to chaos.com/events. There is an event happening a day after this podcast comes out, which is going to be May 21st. It is called From Real Time to Photoreal, Connecting Architectural Designers and ArchViz Artists. It's a really great webinar. If you're interested in that, it is happening, again, May 21st at 4 p.m. Central European Time. Again, 4 p.m. Central European Time. And again, just go to chaos.com/events to sign up for that. Now, if you want to know more about the podcast, our podcast page is chaos.com/CG Garage. If you'd like to follow us on Facebook, it is facebook.com/CG Garage Podcast. If you'd like to watch any of these, all of our videos are posted on youtube.com/Chaos Group TV. As well as these podcasts themselves are also located there. And if you'd like to suggest podcasts, we've gotten great suggestions in the past, and you're welcome to give those to us. Email us, labs@chaos.com. Again, that is labs@chaos.com. But for now, please enjoy episode number 474 with Junaid Baig.
Welcome to another CG Garage, where the Chaos Group talks. You'll know it's over when the last bucket drops. We're gonna fire off rays in high dynamic range. We know that ambient occlusion is passé. Global illumination won't lead you astray. And while image-based lighting is really swell, you need to make sure everything has Fresnel.
But I'd love to hear your background. What's your background? Where did you start getting into visual effects and CG and lighting? You're really a lighting person in a lot of ways, right?
Well, first of all, thank you for having me. It's been absolutely my pleasure to have been speaking with you, your team, everyone. They just bring a completely new perspective to virtual production. So I'm lucky that you chose to work with us. About my background, it goes long way back. It was before Windows, actually. My dad was an engineer, and used to work in AutoCAD. And I was always fascinated by the 3D Studio Max book he had. It wasn't called 3D Studio Max back then.
It's just 3D Studio, right?
Yeah, exactly. So
was it 3.2?
Something like that. Don't remember. It was like it had a picture of a twist deformer which fascinated me and showed me how increasing the number of segments would give you a smoother twisting cube. And back then I was like 5 years old. So he bought me a full version of 3D Studio, and since then I just got hooked up. So
At
it was
5 years old?
yeah, it was DOS when we were running. So just typing in commands, looking at the book, typing in commands, didn't know what I was doing, but essentially like a gradient descent, sort of like learning how what was happening. And then Windows 9,
Amazing.
yeah, 3.1, 95. But then I got hooked. At some point, I thought, I don't want to do this 3D because I've been doing it long enough. It's, it, but I've always been fascinated, obviously, by the work of Pixar. And I didn't even know rendering was a thing back then. I was like, there's a viewport. How does Pixar make it look so good? But
Right.
then later in my years, I discovered there's something called a rendering button, and that changed my life.
Amazing. Okay, so you were just playing around with this was a like your video game at the time, right? When you were a kid.
Oh, absolutely. I think I broke properly into the VFX industry in DNEG when I joined DNEG. I did a few shows fully animated before, fully animated features, and was on-set VFX supervisor for a few things, but mostly in DNEG when I started working on some pre-existing pipelines. So it was one of the first pipelines I worked on, which wasn't made by myself.
Hmm.
And that brought a lot of perspective to my existing knowledge back then of what the pipeline should be and how that should work, and how pipelines could be made to scale to like 12,000 people, and plenty of other things. So yeah, when I joined DNEG, I thought there's a very different way of working in a company of that scale than a boutique studio, for example.
But that is huge. I mean, that is a massive pipeline. What got you interested in pipelines and the process of making something like that?
Sheer laziness, because if I could, if I could if I could automate something and get away with that, I would love to spend time learning how to automate that thing so I don't have to do it myself.
Right.
And then I thought, um, if I would just automate this bit, it would bring ease to my operations, you know. Um, but then I found next thing after that, and then next thing after that to automate, and I realized, well, this is what essentially the pipeline is. Not necessarily to that definition, but that was my impression.
Right. I think it's interesting. I have found that some of the best developers out there are the ones that do it out of exactly what you said, laziness, right? They find a task that they're doing and they say, this is really tedious. I don't want to do this anymore. I'm going to automate this, right?
Yeah, I mean, when I started learning about rendering, I thought that's some sort of a black magic or something. But no, it's really just pipeline at a microscopic level. How do you
Hmm.
stream polygons? How do you stream? Do you actually stream polygons? What the ray tracer is doing. So it's a set of instructions going one after another, and sometimes it's serial, sometimes it's parallel, and how all of it is combined. So essentially, if you think about rendering in modern day rendering, it's a rendering pipeline. It's a graphics pipeline,
Hmm.
which follows the same principles as a studio pipeline, perhaps, but at a much more engineering level.
Sure. Sure, sure, sure. So what got you interested in lighting? What was it about lighting that got you really sort of fascinated with that next level of CG?
Um, I think again, lighting is my background is in photography, and
Ah, okay.
photography and lighting sort of go hand in hand for me.
Yep.
And I think the biggest thing which for me in lighting was I wouldn't have to model texture anything, because I always avoided doing anything with my, like tedious. Modeling is a, maybe some people find it really soothing experience. I don't. I would
Hmm.
rather buy models or use free models, set
Hmm.
up scenes and start lighting as quickly as I could. So lighting always. But I think this is where I was interested in because of photography, and especially how light, just changing the light, changed the mood of the image, and gave a brand new definition to the existing scene. That always impressed me, fascinated me, so stuff. I think it was more of a natural, lean.
Yeah, yeah, that's interesting. I think that lighting was, to me, I was very similar to you, right? I was actually a pretty good modeler. I can't model. I can make a cube now, but I can't model anymore. But I was pretty good back in the day. Tools have changed quite a bit. But I loved lighting, and I think it was a similar thing. To me, it was the physical property of how light bounces around that really kind of got me fascinated. And when I started leaning towards ray tracing, that was the one that really sort of got me interested. What was your sort of thing that sort of like the moment that went, aha?
Mine was actually radiosity.
Oh, right. Yep. Global illumination.
Yeah,
Yeah.
it was that. Because before radiosity came in, it the lighting was more manual, so you would make a spotlight where it falls. You would potentially make some sort of a bounce light from there, like again under the spotlight. Or area lights never existed back then. Area lights actually came properly in a path tracers, in the path tracers, not in the those kind of rasterizers back then. But that kind of thing also tempted me to automate that process. If I place a light, and if I could only find the intersection point, I could place the second light automatically. And I did that to an extent in Houdini. I mean, I started using Houdini from Houdini version 3.5, I guess.
Wow.
And back then it didn't have a lot of what it has now,
Sure.
but it still always had flexibility and not flexibility. The word I'm looking for is potential to expand
Right.
functions. So I made a raycaster. So would place a spotlight, it would cast a ray to an intersection, and then I realized if I'm hitting a table,
Yeah.
I don't necessarily want a light to pop there, but only on the floor. So I realized, how can I query what a floor is? But back then, Houdini didn't have any of that functionality, the query back, and now it has. But anyway, but when Radiosity came along, I was like, wow, that's some sort of black magic. I don't understand that.
And that was with Lightscape?
Actually, it was with one of the renderers in 3D Studio Max. It was a long time ago.
There was Lightscape. That was one of the first ones, I think. That which it segmented all the geometry, right, to all these little points, right?
And then Pixar introduced brick maps.
Yes, that was in 2005 or something like that. Yeah.
Yeah. But yeah, absolutely. And then by accident, I discovered there was a renderer called V-Ray, and that just blew me because I could do just the same amount of work as a lighter, but only leave the computer running to render the image, and it would render a very different image than what I would use to, and it was very, very realistic. But then I decided I don't have enough time to wait for this rendering, and then there used to be something called Mental Ray, and Mental Ray allowed a lot of flexibility and parameter tunings. So I lean more on Mental Ray side than on V-Ray side, purely because I couldn't wait for 8 hours to finish an image. But I always, this sort of went like that. I would render an image with V-Ray overnight, and next day I would start try to match Mental Ray's output to V-Ray. Because Mental Ray,
Yeah, it's interesting because those are the early days of V-Ray. There was definitely some global illumination tools. It was a lot more like correct, right? Like it would ray trace everything correctly, and so you would just work with it. But it was a little there wasn't as many options in terms of optimization, and Mental Ray had those, but you wouldn't necessarily get the realistic thing. So you'd have to work to make those work, right?
Yeah, but then at that time we were used to off working to make things look realistic, and that was the sort of like a your go-to approach. If you're rendering something, you have to make it realistic somehow. Obviously, Mental Ray. I think there was a time I still remember some of those conversations. How many people feel about generative AI today, like Midjourney.
Yes.
A lot of people used to feel something like that about V-Ray back then, that the people who use V-Ray are not actual lighters because the render is doing most of the work. Yeah, exactly.
Yeah. Yeah, I know exactly that. I was like, wait a minute. I'm a lighter. I sit there and I place all the lights that you guys are just using natural ray tracing to do, which is ridiculous.
Yeah,
Yep.
exactly.
Yeah,
But then,
yeah,
yeah,
but
ray
it's
tracing
true,
and
like
path
because I
tracing are
felt,
seamless.
I felt, as a lighting supervisor, and you've been a lighting supervisor too. I remember when we were working on shows where there was still rasterizing things, and on a big show, you basically had, one lighter could light about 25 shots because it took a lot of work to light a shots, and then
Yeah.
now, 100, 200 shots, 300 shots for one lighter, easy
Oh, yeah.
because everything is ray traced. You don't have to sit
Yeah.
there and try to match reality. It just does it, right?
Yeah, exactly. But path tracing has been a big one because path tracing, I learned ironically path tracing before ray tracing. And I always thought because writing a path tracer is slightly simpler than writing a ray tracer
Mm-hmm.
because, well, especially at least for a lazy person, because for ray tracers, you have to, like in path tracers, there is no concept of direct or indirect lighting. It's just
Mm-hmm.
illumination. And ray tracing, you have to break out just direct lighting, shadows, indirect lighting, stuff like that.
Right.
Which means you have to test for intersections. And anyway, writing a naive ray tracer is still, in my opinion, is slightly more difficult than writing a naive path tracer.
Oh, interesting. So you wrote your own path tracer?
Oh yeah, many times, and ray
Many
tracers as well.
times. Many times. Okay. Yeah, it's interesting. I've seen people who are learning to program and learning computer graphics, and that's one of the first things they do is they write a ray tracer on their own, right? Just so they can figure out exactly how that works.
Yeah, I think it teaches maths, the fundamental concepts like how do you utilize cosine, for example,
Mm-hmm.
or what do you mean by intersections, and how do you store intersections in an array? How do you anyway? I can go on and on about those things,
Sure.
but essentially, I wrote I wrote a ray tracer in Houdini soft, which performed optimization of the scene in an offline manner. So I would run. It was for a show. Maybe I can say now. It
Mm-hmm.
was for one of the Fantastic Beasts shows,
Oh, okay.
and there was a lot of geometry in the scene, which we were not able to fit in the memory. So instead of relying on optimizations here's the notorious thing: if you throw 100 million polygons at a ray tracer or path tracer, it has to intersect them. I
Mm-hmm.
mean, in one way or the other.
Mm-hmm.
It has optimizations built in, but what if you could throw less number of polygons to begin with, which it won't have to fit in memory. So I wrote a ray tracer which would go far away the distance and see if the pixel actually the geometry a cell in geometry could fit more than 2 or 3 polygons, and it would try and combine all of them into a point cloud and
Mm-hmm.
get the average color. So and it would then cull all the geometry into a new subset, um, which would go to renderer. It would mean, or what it actually meant was, we brought down our memory usage from 112 GB down to like
Mm-hmm.
16 GB or something, because we
Right.
were just throwing a lot less polygons to the render, and visually no one could tell the difference apart.
What's interesting is actually, I wanted, because you're the perfect person, so we're going to discuss how ray tracing can manage lots of geometry. But
Yeah.
let's talk a little bit about ray tracing acceleration. How could you describe? Because there's obviously BSP trees and all these different accelerators that exist in ray tracing. Let's explain to some people, how does that work? How does an
Well,
accelerator work?
l- l- well, let me explain that in the modern language, like on a GPU, for example.
Sure.
A lot of the GPUs, like NVIDIA GPUs, for example, which is quite common product, they come with a acceleration structure which has two kind of levels. There's a top level acceleration structure, and then there's a bottom level acceleration structure, TLAA and BLAA. Um, Both of them follow a heuristic called bounding volume hierarchy. So essentially, if you think about what you're seeing here, this whole room would be one large bounding box,
Mm-hmm.
and the curtains back there would have their own bounding box, and this person in the chair would have its own bounding box, and then
Right.
this person would be another bounding box, stuff like that. So
Right.
ray tracer in the beginning, wouldn't see the geometry, the real geometry, the triangles. It would only be seeing bounding boxes, which are much more effective. So when a ray intersects a specific bounding box, it unpacks the content of that bounding box, and which includes another bounding boxes. And if the ray hits that bounding box, so you can see it's sort of like a recursive operation
Yeah,
until
like a
it can
hierarchy,
unpack to a
right?
level. Yeah,
Yeah,
yeah. Until it can unpack down to the triangle level. And if it unpacks a triangle, the ray intersects against that triangle and tests and just record that as an intersection point. It doesn't do anything more than that at this point. But
right.
array has to complete its course all the way down and has to do the same thing. The acceleration structures are really important because it allows rays to skip the objects it's not going to hit. So they are like my home has many other rooms, and if the camera wasn't looking at any other rooms, only their bounding boxes would be loaded in the memory, not the full geometric representation. But if there was no any acceleration structure, all the geometry had to be loaded into the scene to be tested against, just to find out whether a pixel is actually hitting it or not.
Yeah. That's it. First of all, thank you. This is a great description. We need these moments to explain to people. And how is that different in rasterized rendering? Like, why does rasterized rendering not work with that same acceleration structure and hierarchy?
But I said things like top level acceleration structure and
Mm-hmm.
bottom level. So
Mm-hmm.
let me start with that. So top level acceleration structure always lives in the memory, always computed per frame. Top level acceleration structure contains the information of everything in your scene. So the word is it contains the information, not the actual triangles. Bottom level acceleration structures not updated per frame. They are only if they are only required by the top level acceleration structure when it requires it, only then they get unpacked, right? In all of this instance, there is no such thing as Z buffer. It's only acceleration structure. Rasterizer has a concept called HSB, which is hierarchical Z buffers, which so the way a rasterizer works is essentially it looks at the pixel, it knows the position of the pixel, and then the camera doesn't cast a ray. The camera says what is covered under that pixel. So it goes about testing everything under the pixel, and it starts drawing all the shapes on top of each other. Once it finishes, let's say, I'm just oversimplifying it. Once it
Yeah.
finishing understanding the shapes, then it has to define what the order of those shapes are, which shape is in front, which shape is in the back. That is
Right.
where HSB comes in. So again, rasterizer also has to trace everything all the way back to the limit of the depth and start computing the order and then start drawing on top of it, which
Right.
this is where your overdraw comes in essentially. Uh,
Right.
there's no real concept of overdraw in ray tracing. Again, this is not a 100% correct statement, but it's a very simple statement. Yeah.
Yeah. Okay. So this is interesting. So in a sense, a lot of ways, the rasterized renderer sort of has to look at everything in the scene to know what order everything is in, right?
Under every pixel.
Right, under every pixel.
Yeah.
Okay. Very good. All right. All right. We're going to
There are
get back to.
benefits.
Yeah. Go
Yeah,
ahead.
so just want to clarify. There's a benefit to rasterizers and there's benefit to ray tracers. The
Yes.
benefit to the rasterizer is it doesn't need to load the whole scene in the memory. It just has to load the pixels
Right.
or the scene or things which is under the pixel. Ray tracer has to load everything around a certain volume in the memory. So modern applications like Unity or Unreal Engine has optimizations built around that. So just to be very clear about that, wherever your camera is placed, there is something called culling radius, which is one of the well, culling radius is how far away from the camera you draw a circle, and what's the radius of the circle, and just keep only that thing in the ray tracing memory into the and form acceleration structure around that. Then there is something called culling angle, which says although you have kept things under a certain radius in the memory, if the angle of incident from the camera to the object is say less than 5 degrees, don't consider ray tracing against that object. These are the optimizations built into the ray tracers. You don't necessarily, even if you're seeing things at a really glancing angle, there's a good chance that you might not be even ray tracing against that object because it's not pulled from the bottom level acceleration structure to be traced against. Hopefully it's not confusing.
Yeah. Okay. All right. Well, this is good because this will get us into real-time stuff at some point. But so you were when you're at DNEG, you were obviously you were working on pipelines and you were interested in lighting. And lighting is a big part of pipeline, right? Because it is one of the most computational tasks that are done in a visual effects studio, right?
Yeah. Yes. Lighting, effect, rendering essentially. So I was a rendering department supervisor and worked with a lot of really, really talented people. I cannot take any credit of the work they have done. My only job was to make sure that we deliver the show within the resources and the time, and somehow look at managing the render times as well, and perhaps come up with technology with our vendors, with our developers to optimize renderer for the scenes to just keep pushing the boundary, I guess.
Yeah, I mean, I guess that's the biggest task, right? You have to look at your resources, and there's also like this game of like how many nodes do we have, and what's the average render time per node, and all that stuff, right?
Exactly.
Yeah, network speeds, all this other stuff.
Yeah. It's rendering is interesting because it's like well, a part of my background. I learned myself hacking. And cybersecurity and stuff like that, purely out of interest. So rendering on a render farm at a studio level is more like denial of services attack. So if you're not careful with your resources, how you're handling resources, you could bring the server down. If you're pulling a lot of data, I can give you an example if you're interested.
Yeah.
I don't want to name the show, but there was a major show we were running. It was, and we were using 16K textures as we do. One of the textures wasn't mip-mapped, and it was used in multiple locations. So a lot of the nodes were rendering that specific texture. So, and because it wasn't power of 2, couldn't be mip-mapped properly, a whole of the texture had to be loaded. There's an attack called Rudy, which is RUDY, short for Are You Dead Yet? If you read about that, it's really it's parsing a very long string to a server to keep the port open, for example, and make sure that server is never able to release the resources to do any other computation work, and the queue just gets longer. So this is exactly what happened. All the machines at some point got so slow in the network while that shot was rendering for hours. Nobody in the studio could work. And I'm talking about DNEG here. Yeah. We figured out where the problem might be. There were some really smart people in DNEG IT, worked with them, figuring out why it was happening, and then we fixed that one texture. Wow. And that solved the problem. So, sometimes things like these could creep up.
Yeah, and that affected the entire studio. It wasn't just the rendering part of things, right? Everything was slow.
Because it affected the server, essentially.
Yeah.
So everyone who's connected to that specific server got affected. Obviously, It was just like 15, 20 minutes.
Right.
I think got resolved. Nobody missed any deadlines but
sure.
Many people probably don't even know. They just thought, well, just network is acting weird. So that was the reason.
Wow. Yeah. I mean, these things happen. Like a lot of these random weird things happen for sure. Well, very interesting. Okay. So you got into virtual production at some point. How did this start, and where did that journey come from?
I remember it was 2018, I guess, when Epic showed the Stormtrooper demo with ILM. And they said we could do ray tracing in Unreal Engine. So I thought that was a gimmick. It was like smoke and mirrors. It wasn't a reality. And because how could you do ray tracing in real time and like in a playable manner? I mean, obviously they have been real time ray tracers, but when I actually started with Unreal Engine, and I had a Quadro GPU back then, which didn't necessarily support ray tracing. It was it was the time when RTX GPUs were coming out as well eventually.
Yep. 2020, the 2080 was the when the was launched.
Yes. Yeah.
And we did, that was when Vantage, which was called Project Lavina at the time, that's when we launched it. And it was designed specifically for that GPU as well.
Brilliant.
Yeah.
Well, so that was my entry point. I thought, what can we do with this? So back then, I didn't even know there was such thing called virtual production. And I opened an environment we did in Clarice in DNEG. In Unreal Engine, and rendered something from Unreal Engine 4.2.4 actually, with ray tracing, and showed it to one of the VFX who on the show. Obviously, I can't name the shows now, but he said, who worked on the show, the VFX who, he said, I can't tell the difference apart between which one is which. Both of them were slightly different in their own sense. Obviously, one of them was path traced, the other one was rasterized plus ray traced. But the fact that the VFX soup on the show commented that it's very difficult to find if I have to be very closely inspecting both of the images to figure out which one is the path tracer, which one is the ray tracer, was a testament in itself that the technology is it was a very complex scene given that, but still I was able to fit that in memory, and later in 2019 I started DNEG and Dimension collaborated to do the first virtual production, I remember, from Paul Franklin's project. It was a Paul Franklin's project called Fireworks. That's when I got properly into virtual production.
So was it virtual production through LED volumes and camera VFX, or was it virtual production, just virtual camera stuff?
No, the former, the LED volume and camera stuff.
Right. And so what were your thoughts about that? Like in terms of like what that meant in terms of how filmmaking was going to be and how visual effects were going to be?
Well, I'm amused, but it certainly changed the landscape of filmmaking, especially after, the Mandalorian essentially just convinced a lot of filmmakers that you could use this crazy technology. And it certainly convinced me to look at it from the angle where I was rendering 37. The shows we have worked on in DNEG were about, 7 hours a frame, 37 hours a frame, 50 hours a frame, whatever. Some cases, and sometimes it's like less than an hour a frame. But it would be like, we don't even count for frames which take less than an hour to render, and all of a sudden I'm rendering of quality which is good enough for the director at 24 frames per second. So how is that even comparable? So that I questioned myself about, why are we spending so much time on rendering the frames in a VFX setting where frames like 24 frames per second are still good enough for the directors to be, to just give thumbs up on that shot as a final in-camera VFX, and in most cases. And mind you, one thing I've learned is ICVFX doesn't have to be a binary choice between whether a shot is fully VFX or not fully VFX. You're still gonna go treat that as a plate and add elements to it if you have to, like explosion or monster or whatever, which you probably can't achieve in ICVFX purely because the asset isn't ready or isn't scheduled like that. But still, so it cannot be treated as a fully VFX shot, even if you shoot it in ICVFX setting and has to have some VFX elements later in it.
Yeah, I hear what you're saying. It's interesting to think about that. But you've seen, you got involved in ICVFX very early, right? It was a very early process. So over that time, you've seen some evolution. You've seen evolution in technology. You've seen evolution. So what were some of the sort of landmark things that you saw, like, the panels, like the resolution of the panels and all the camera tracking and all these things? What were some of the challenges you saw at first, and how did they get overcome over time?
I think I don't see those things as challenges or problems. It's just probably the way I think about things. I saw them as, I mean, even today, I won't go about complaining things. I would go about accepting the fact that this is how the things are and what can we do to change them moving forward. But currently, there are certain limitations. Obviously, there are panels which are very high resolution, um, but is there a guarantee that we are going to be able to shoot in those panels if production didn't have a budget to hire that studio which had that high quality or high resolution panels? So question number one. So if I don't have any control over those kind of things, then I just stop thinking about those kind of things, I guess.
Sure. Well, what are okay? So let's go step back. So now, what is the challenges if you're going to set up a virtual production stage and you want to do something in that way? What are some of the steps you need to do? Like in terms of building out, what are the things you need to consider building out the stage, and what are some of the things you need to consider when you're building out your studio in terms of how the work is done for it?
Well, I think the biggest challenge remains the content.
Mm.
I would argue that the biggest challenge is not the space itself. You can expand the space by just throwing more money at it. But you cannot just increase the quality of the content by throwing money or resources at it. It has to come from a genuinely good artists. And if that's not the case, then there's we are, if for the Venn diagram, there's a lot of potential, or there are a lot of potential hires from the game industry, and there are a lot of potential hires from VFX industry. In virtual production, it has to combine them like this, and this is where in the middle, virtual production, high quality asset creators live.
Mm-hmm.
Um, they have to have the mindset of optimization as the not the afterthought, but as something which is built into the assets, and they know how things are gonna be impacted. Um, and VFX people, and the same people have to know how much to push the texture, how much detail they should put in an asset. Because the fact of the matter in ICVFX is it's hardly ever gonna be in focus. You just cannot focus on the wall so far,
Mm-hmm.
because of camera resolution being higher than the LED volume resolution. Even if I just focus my camera on this monitor, my everyday monitor, uh, I would still see more pattern,
Mm-hmm.
So obviously we cannot focus on the wall. But then those assets could potentially be used by VFX in the future, or further down in the pipeline. So they have to be at a certain quality level. You know, it's a balancing act. So for me, it needs to be a content. It needs to be a content challenge than the hardware challenge, I think.
The
Or
content
LED volume
challenge
challenge,
is
yeah.
the content challenge is still the biggest challenge in visual effect in ICVFX.
Yeah, I would, at least in my experience, I could be completely wrong.
Yeah. Okay. Uh, and yeah, it's funny. Well, I heard a great term. Like there's that someone was joking about, especially in technology, a lot of people think you can just throw money at a problem and it'll get better. And it's not true. And it's sort of like, saying, I want this horse to be a Pegasus, and you're just going to throw money at the horse, and then suddenly it's going to start flying, and it doesn't doesn't work that way,
Yeah.
right? I think it's a really good thing. It's like, and I also think you're right. I think the quality of the artist, and it's nice to hear you say that as someone who really deals with technology. The quality of the artist is the secret sauce that makes something great, as opposed to the
Yeah.
actual technology behind it.
I mean, if you think about this, regardless of the technological limitations of past, say, 2, 3 decades, artists have successfully created imagery which has inspired everyone. So if I'm an artist, technology is probably not the limitation for me. And the only thing technology can provide is it works as a support to the artist. It needs to empower the artist. So technology doesn't need to redefine the way an artist thinks. It needs to complement the way an artist thinks.
Yeah. I think that's a really Really nice way of saying it. And I think, my good friend Ian Spriggs, who does incredible portraits of people, he's inspired by Rembrandt, right? And he always says, like, Rembrandt does beautiful portraits of people, and he did it ages ago. And I do portraits that are inspired by him, and he didn't have a computer,
Yeah, true. Exactly.
But he had technology, right? He had technology of the way that he thought about paints and the chemistry that he was using with paints and things of that nature, right? So those were very specific ways of looking at things.
Yeah, I remember it was for a brief period of time, I was part of a project in DNEG which studied the blood flow to return the color on the skin. So it would, right? And we would never ask an artist to dial the blood flow in the creature. It needs to be that operation needed to be completely transparent, so it doesn't obstruct the way an artist would work. We still would go ahead and say, just use this shader now with your existing maps, and it should produce significantly scientifically accurate result. And if an artist doesn't like that, then they're not going to use it, right? So it doesn't matter how physically accurate the result is. An artist needs to like it. A director needs to say, yes, it's looking good. A VFX supervisor needs to say, yes, it's pretty convincing. So obviously science is going to keep bringing the imagery closer to life. But again, it's really down to the artist to dial those things in eventually.
Right. Okay, so let's talk a little bit about your, you've done a few other things here and there in terms of virtual production. What was some of your other journeys? Where did you go from there?
I actually remember one of the, I was on a show, Pinocchio, recently by, which is on Netflix as well, or Disney Plus. Anyway, we were on the set. It wasn't in-camera VFX. It was it was all blue screen, and there was a sequence, dollhouse sequence, because the show is released now, I can say. And we were working on. I was part of a really talented team, but something which really you could say amazed me, or I felt a bit proud about that, was director came over to our team, VFX team, VP team. They said, with the VFX soup, they said, we were able to use your technology, which is, it was just an overlay, like a virtual camera system. And they said, we were able to use your technology to lay out the camera and track the camera in a way. If ordinarily we would have done, we would just done a fixed camera and animated that in later. But now we were able to actually do the camera movement based on the imagery you provided. So obviously it was Dimension, which was which was running the show. It was very nicely delivered, and everyone was so happy. Again, technologically, it was our job to make things work, but the value it added to the filmmaker, to the director, and the VFX supervisor, that was the real thing, because this is why we were doing that. We were not doing it for us, we were doing it for them. And if they were happy, then, that made all of us very happy.
I think this is a very good point, and it's come up many times when I've talked about in-camera VFX specifically, is, there has been over the last, several years or decade or so, sort of a backlash against computer graphics by filmmakers, because in my mind, I think what's going on is that they're looking at what they hand over plates and then they hope for the best after 9 months it comes out, right?
Yeah.
And then with in-camera VFX, we are giving them back their film and they have control over what they're doing. Even though it is computer graphics, they see it and they can give direct feedback in real time about what they're actually doing, right?
Yeah, absolutely. It's a learning curve because, VFX, the artists never had to deal directly with the director's input,
Right.
And now, obviously, both of the parties don't speak the same language. So it's a bit of a learning curve for both of them. And I'm, both of them are doing a great job in working together and learning more language. So I think it's really beneficial because artists who get a chance to work on set, work with the directors and the DPs, they actually know for the next project what how how to author the content, where to put more detail, what is more important. So they don't want to necessarily uh, texture paint a building which is probably not going to be visible. So they're probably going to use some generic textures on it, stuff like that.
Sure.
But ordinarily, you wouldn't know these kind of things beforehand. So you would just go about texture the whole building. You probably won't even see that. So I think it's more fruitful in knowing that the art you are producing is actually going to be in camera.
Yeah, and it's true, right? Because they operate now, you have people that are operating much closer to an actual set builder, right? That are actually, they paint only the parts that are visible. They're not painting the backside of the wall, right?
Yeah, exactly.
Yeah. Interesting. I think that's really good. And I think it's kind of an enlightening experience. I mean, I know from a lighter, right? I had this conversation. I've recently been working on an in-camera VFX show that I've been doing for our test for Project Arena. And, working with the DP is so much nicer because the DP then is making the lighting decisions, right? And before I would be given a plate and I had to put a robot in the plate, let's just say. And I had to guess, like, how do you think the DP would have liked this robot to be lit? And I'm I'm sort of guessing what it is. And I'm not a bad lighter, but it's also not my film, right? It's a different choice. So having the DP look at that robot live and say, oh no, I want more rim light, or I want this, or I want that, is nice to have that, give that power back to the filmmakers in some ways.
Yeah, 100%. It reminds me of one of the experience of it was on Masters of the Air, and Lux Machina was running the show. Phil and Chris and others. They were running the show, and they were working so closely with the director, first director, the DP, that it felt, and the VFX supervisor, of course. It felt like a teamwork, essentially, and that was the first time I saw this kind of teamwork happening on set between VFX and the filmmakers. Previously, obviously, I worked in VFX for a long time. I never saw that connection. I never saw the feedback coming directly from the director to the artist, both of them standing next to each other, discussing lighting with the DP. Now that was really enlightening. It was enlightening because I think, to Lux's credit, they had an amazing system, and I was lucky enough to join them for about a year and work with them. Excuse me.
Phil was on the podcast, by the way. He was on.
Oh, really?
Yeah.
I should catch up on my podcast.
It's coming out very soon, so you'll probably see it next week. But yeah, he was on very recently. I just recorded one, so yeah.
Brilliant.
Which is cool.
He's a phenomenal person. Well, in all fairness, I've been really lucky. I've always worked with very nice people around me. So don't want to jinx that.
Yeah. But yeah, tell us a little bit about that experience of seeing them work with the DP. I mean, when I worked in dailies, go to dailies and there's a director that comes there, but a DP is hardly ever in the dailies room looking at visual effects shots, right?
Yeah. There's simple things which we don't even consider to be a thing as such is the color of the sky, the shade of the blue, and how that affects the emotions in the frame. Now, these are the kind of conversations any VFX, at least when I'm still in VFX, but when I was just sitting behind the desk doing things, I wouldn't even bother about the emotions in the frame. It would be more like match this color with this color and the shot, and then it would go into the grade, and then there are other devices to work with, but the point is when you witness this kind of conversation, the more we do these kind of things, the more it's going to create the next generation of artists who are going to communicate in the same tone, and eventually will come to the converge to a language which DPs, directors, VFX artists, all of them would sort of agree upon and just speak in the same language, because currently there is a big disconnect.
Yeah, I think you're right. And I think it's interesting when you think about you see in camera VFX that now VFX artists are going to be much more on set, right?
Yeah, or at least be more directly engaged. I mean, specifically talking about Masters of the Air, for example, a lot of the shots had VFX later on in them, but it was, again, as I said, it wasn't like full VFX shots on all of them. It was there were some shots which were fully VFX. There were most shots which are fully VFX, but the fact that also the actors, if you think about the actors, they were sort of immersed in the experience. They know what they are reacting against or reacting to. They could see airplanes coming in left and right while they're sitting in the cockpit. So it was more like them being in a simulation rather than just pretending that what was going to happen eventually, or they were just in front of blue screen. So I think, yeah, obviously it's tiring to the eyes as well.
Yeah.
Being in a large LED volume all the time, like for 10 hours. But I think it has its own benefits as well.
I think my first time sort of really hearing that direct feedback was I worked on Oblivion, which is one of the things that Phil had worked on as well, and they did all the the front projection stuff of that entire sky town like house, and it looked really gorgeous. But I remember because we had to do stuff with Tom Cruise, and I was lucky enough to spend a little time talking to him while we were waiting for things, and he was talking about that house. He said it was the best because he says the mood was set by the environment outside, and he could feel like, oh, it's sunset, so I feel like it's sunset, and I feel like it's the evening, or I feel like it's in the middle of the day, and it was I don't care how good an actor you are, acting in front of nothing, it has to be hard in some ways. Yeah.
Exactly. Yeah.
Yeah. So let's talk a little bit about your current title at DNEG. Is it Head of Applied Technology? Is that what it is?
Yes,
okay. So what does that mean, and what is your responsibilities there now?
Well, it's DNEG 360.
Okay. Yep. DNEG 360. Explain what that is.
Okay. DNEG 360 is it's going to sound cheesy, but all the services under one roof. So 360. Essentially, from previous pitch-based work, previous work, tech-based work, your virtual production, which is whether it's in camera or not in camera, but simulcam, your virtual camera, motion graphics, and final VFX, final pixel delivery, compositing, each and everything under one roof. Plus, there's Dimension, which provides the volumetric capture, motion capture, and a couple of other services, which are like your innovation projects, your MetaHuman. So there are just a lot of departments and very, very essential departments which would support the filmmakers. What my responsibilities are in all of this as a head of applied technology is, if you think about, generally, I describe it like this: there's a theoretical physics, and then there is applied physics. So there's a technology side which includes your research. There's pure research, academia, and then there's technology that supports pipeline. So applied technology is actually technology which you can actually apply to productions and to the company, which also has a bit of a flavor of research, but it's not just pure research. So suggesting things like, we don't work on redefining how subsurface should react, but what we do work on is we study papers and say, is this something we can implement in a real-time renderer, which can help the artists? So instead of thinking about new ways of subsurface, we start reading papers and see what it is out there and see if we can collaborate with the university. And that's just a very low level thing. We work on modifying the renderer itself to support artists. So us not redefining how artists work, executive producers think about the show, we just help them support and provide the infrastructure which no other studio can provide. It's really thanks to down to the vision of the leadership, which is so all the technology, the applied technology initiative is actually driven by the core leadership of the company, um, and they have it just reflects in the ethos. It's part of the ethos of the company. What we do is we cater to our producers, artists. When I say artists, I stress on artists because I think DNEG 360 and Dimension have done an amazing job in collecting some of the best artists and people from the industry. And I want to stress on that in these difficult times, and where our industry has been due to strikes, various strikes, Dimension and DNEG 360 hasn't made any pay cuts or made people redundant or taken any short-term measures. So this sort of shows how much value they give to their staff, the people they're working with, um, despite not having as many productions normally as we would have. But still, in anticipations, we are now working on retraining the artists we have to create even higher quality, even better quality content, which can directly go into ICV effects. So you
Okay.
asked me what I
Yeah.
do, but I think because I work interface with all of them, it's really important to highlight this fact as well.
I think that's really nice, and it's really good that you were able to say that, because I think it's good that you validate the artist, right? Because I think sometimes in certain companies they value the technology over the artists, and that is not necessarily the right thing. And the fact that you are the head of applied technology and you say you value the artist above the technology is nice. But I think it's
Thank you.
hard to quantify. It's hard to quantify. I think for a company, sometimes it's hard to quantify the quality of an artist. It's easier to quantify the quality of a technology, right?
Yeah, but in my experience, if the leadership values the technology, then it becomes less of a, let me rephrase that. If the leadership values that know the value of the technology, they understand that technology is essential for the business, then we won't have to defend the people working in the technology all the time because they are already ring fenced by the executive leadership. You know,
Right.
and we are very lucky in that sense that we are very experimental in approach, and obviously any kind of experiment costs money, which comes from executives. So if they are allowing this kind of culture to brew in the company, then hats off to them. But I definitely want to say that within applied tech, within the technology division, we have some of the best people. We have people who look at machine learning, 3D machine learning, 2D machine learning. We have people who work at core rendering level. We have people who work at integration level, which is connecting various software together. And we're certainly coming up with next generation of products. And we have people who are very specialists in pipelines. Um, we have our staff which has very much DevOps mindset, and we are working towards the automation of the a very typical DevOps operation, but also expanding it in all what we do. If we can't apply on production, we don't work on it. It's as simple
Right.
as that. If the work we are doing is not gonna help the artists and the filmmakers generate higher quality content and bring their vision to life with ease, there is no need to do that kind of work.
Yeah.
It's
Yeah.
the philosophy is
Interesting.
simple. Yeah,
It's interesting. Okay, I do want to go, because obviously I'm curious because I've been spending so much time focus on some virtual production tools myself, as you're well aware.
yeah,
What are your thoughts about where virtual production tools are going? And you obviously you have some concept of what we're doing with Arena, and I'm just wondering, you're
yeah.
curious about your thoughts on that. If you think that there's what are the benefits of that direction, or if you think that there's other things that things that we all should be looking at in some ways where that goes.
Arena is really good. I mean, it's a game changer. That's my. It's a solution which is laser focused on. Uh, it's disruptive in nature. I want to say it like this. While so am I free to talk about my opinions on Arena, or do you want?
Yeah, of course.
Yeah, okay, good. All right. So think of Unreal Engine. It we have to train artists to create high quality content in Unreal Engine. We have to train them to. When I say we have to, it means we have to look at artists who work in VFX and change give them understanding of how to actually work in real time context.
Hmm.
So there is a bit of a learning curve. Not saying it's a bad thing. It's definitely making an artist more employable, for example.
Hmm. Sure.
However, from a pure production point of view, um, what Arena does is it says keep working the way you have been working, and we'll take care of the real time aspect of it. So you do your work, you click a button, and the thing goes to stage. On stage, there are far less buttons to press. There's You just load up the project. And I know you guys are planning to come in as well in our London studio.
Sure.
And I think we would be able to demonstrate that from currently talking about the ICVFX part of it.
Right.
We load up the scene, everything is just working. Your camera tracking is working, your prop tracking is working, your fresh jumps are working fine, um, and you just start shooting, right? It's that simple. Because you have simplified the production pipeline, and I know we have spoken at length about how it can benefit daily sessions, for example, and
Hmm.
that's my second point, segue into that we can produce higher quality visuals directly from Maya at real time, or Houdini in real time,
Hmm.
near real time, submit to farm, get an image very, very quickly, all while staying inside Maya.
Right.
Or I keep saying Maya because that's a pre-visualization pipelines built in Maya, but then we have Houdini, which is our primary software. So, just keep saying Maya because we're working with you guys to do
Right.
this in Maya. But Houdini
Sure.
obviously as well. So I'm just trying to be, not take names here, but
Right.
essentially allowing us to keep working, just recruit people from the VFX industry and let them produce the best work and not care about rendering as such, because it is always rendered. So that's yeah, it's really powerful. That's why I said disruptive, because that's not what we are used to. We have become used to of doing things the way we would do with Unreal Engine, for example, or
Right.
Unity maybe.
Because there is a ton of time spent on optimization and then conversion, right? And that's sort
Yeah.
of, we eliminate a lot of that process.
Yes, that is true. Your some core technologies are just amazing. I mean, the fact that you're fully ray traced render, you do DLSS
Mhm.
integration at a rasterization level. Um, yeah, it's just, I'm being very mindful not to speak about too many things.
Sure.
Which, yeah,
One
but
thing that sort of blew my mind a little bit, because one of the things I was thinking about, like, well, how could I, what I use? And we're working on this scene, and I'll just say it involves a train, right? So there's a train going down the track. But I wanted to I work with these guys in Germany. They're a company called The Scope, and they create beautiful environments for car stuff mainly, and that's their main focus. But they can do anything. So I said, let's work with them and create this environment. And we created this, about 5 kilometers of track and we put every blade of grass, every tree, everything in there. It was 2 trillion polygons. And it was rendering at 60 frames a second because it just didn't care, right? It's a different way of thinking, right? Because you don't think of optimization the same way. You have to think of the scene in a different way when you do that, right?
you know, this reminds me when you and your team were over there in DNEG,
Yeah.
we uh, you had an image up, which I thought now this is part of the presentation slide, and it was a picture of an HDRI, and
Right.
your team started speaking about rendering and the
Hmm.
technology and the product. Then all of a sudden I saw this image started moving, and I realized that was not the image. that was vintage. It was rendering real-time, photorealistic. And then he
Yeah.
went all the way to the blade of the grass and said, look how it's casting shadow. There's an ambient occlusion effect happening. It was not screen spaced. It's like, wow, that it fooled me. I thought it was
Yeah.
an HDRI.
Yeah.
And yeah, so that's when I moved to the edge of my seat, like, wow, what's that?
Well, it's also the same thing, right? Let's go back to your conversations. When way back when you started getting interested in global illumination, right? Because I was working with a DP, and he was like, "I can move a light, and everything changes correctly. I don't have to bake the light again. I don't have to do all the fakery that we were doing before." Right?
Yeah. Yes. Obviously, being very realistic, it's gonna be challenging when we move into when we start supporting vintage,
Mm-hmm.
because challenging for us because we have a lot of tools built in Unreal Engine, but
Sure.
there has been a big effort. If you look at there are companies who are building tools which are agnostic to the host application, so you can plug them in. Like there's a company called Dash, or a product called Dash, which is agnostic to Unreal Engine, so it would always work
Mm-hmm.
outside in a core library. It has a core library, and then you have plugins to Unreal Engine, or maybe perhaps in Maya as well. But this is where what we are trying to do as well. So we are trying to build tools which are agnostic. There's a huge effort underway at the moment to provide tools to make tools in a very much agnostic manner, so we can feed them into whether Unreal Engine, whether Vintage, or who knows what next. I sometimes, I still remember you showing, what was that when you were rendering in real time. It was like long time ago when you could. What was the example when you were rendering on 12 GPUs at the same time?
Oh,
Real-time
the
retracing.
construct project.
That
Yes.
one. Yeah.
Yeah. We actually, we did. So it was actually 32 GPUs. It was ridiculous. But,
32.
yeah, we did. It was 4 VCAs. Each of them had 8 GPUs in them. So it was ridiculous. But that was that was before things like DLSS 3.5 and ray reconstruction, right? So
Yeah.
ray reconstruction was the thing that really sort of changed everything, right? Last
Yeah.
year,
Yeah.
like when that came out, it's like, okay, because you're getting clean renders at a very high resolution now. And it was the one
Yeah.
downfall of ray tracing. It's like, it's always going to be a little bit grainy and you're never going to get the high resolution. And DLSS 3.5 came along and it just changed all of that.
Yeah, exactly. Yeah, that's a game changer. I know you probably know as well. There's a lot of good technologies coming from NVIDIA. They
Hmm.
are, and we're really keen on adopting them. I mean, as a matter of fact, we have adopted quite a few of them in our custom version of Unreal Engine. So like we can support about 1,000 shadow casting lights in
Mm.
real time. Things like ray reconstruction is built in our version of Unreal Engine.
Hmm.
The caustics which we have built, but the way we have integrated all of that is we have sort of dissected Lumen pipeline, ingested caustics in
Hmm.
Lumen. Um, so interesting work done by the amazing team in Applied Tech.
Yeah, for sure. I think that what another thing that some people or artists may not realize is that all this is actually they're AI tools, right? They're machine learning tools that have created this and enable that kind of acceleration, which I think is really an important part to realize. Like those are some of the AI tools that people should realize are not taking their jobs away. They're just making their jobs better.
Yes, yeah, that is true. It's a sensitive subject.
It is.
The Yeah, you obviously there are pros and cons of everything, but image generation AI at least in my experience, I've been privileged to have worked with some of the greatest artists in the industry.
Mhm.
And I am yet to see anyone in the position where they create the first artwork which gets approved by client.
Mhm.
So you always have to have iterative approach to your art. And where AI is now currently, you might get more control in the future, but accepting, again, working with in the industry with filmmakers, it just never happens, So I don't think AI is going to steal jobs. I think it's just going to increase the throughput of the artists, or give them a bit of a head start on things.
Sure. I've seen a lot of art being created with certain generative tools, even Midjourney or whatever.
Yeah.
And the bests that I've seen come from artists, real artists,
Yeah.
right? And they almost never accept whatever came out of that. They always take that as a basis and then work on top of it iteratively, right? So
Yeah. Yes. So obviously there are artists' concerns about the data it has been trained on, etc., etc.
That's a very valid concern.
Yeah. Yeah,
Yeah.
exactly. There's just no argument against it.
Sure.
But the fact that it exists, it's going to remain, and it's going to remain. It's going to be improved. So it might as well just, instead of turning a blind eye towards it, you have to think about how you can make use of it to do your job.
Sure.
Or again, I said I don't want to be insensitive. I am an artist by nature. I still don't use Midjourney or Stable Diffusion, not due to spite, but because I don't think I can make art with those tools just yet. I don't think I'm ready for those kind of tools. Maybe there are other people who are.
Right. I think it's, well, I agree. I think this is a very long subject. We're already over an hour. So, but but I also think that it's a wonderful, I always try to stay optimistic about things, even in times where people are worried about all of these things. And I think that the concerns about copyright are extremely valid. And I think that these things need to be decided in the proper system and courts of law, and not necessarily courts of public opinion, right? I think that's a very important part of what needs to happen. And I believe that once they do, we will be able to manage those better, hopefully. But at the same time, it's the fact that so many more people are interested in art now than they ever have been is wonderful. And I think there's so much creativity coming out in the world because of an interest in art. And I think that AI tools, whether have enabled people to feel that they have a power to express their creativity in some ways.
There are other ways. I know, like, you've showed me, and Epic Kiosk has generally, I think Kiosk had a general presentation about the AI initiative within Kiosk, about scene assembly, scene construction, layouting, stuff like that. I don't really see that as a problem. I really see that as you're giving power to the artist, so you're giving them a head start. It's like, it's like suggesting, again, I know it's not an apples to apples comparison, but I don't want to be insensitive. So I'm not really comparing it, just being really cautious about what I'm going to say. I can still go ahead, download the models made by real humans on my computer and assemble a scene with it and say, well, this is my scene,
Right.
So yeah, just want to end my sentence there.
Yeah. I understand exactly what you're saying. I understand it. Yeah, absolutely. Well, listen, Junaid, it's been a fascinating conversation. I know that technology is going to continue to change, and you're going to be on top of figuring out how to apply it to all the wonderful things you guys are doing at DNEG. So as such, I am sure I'm going to reach out to you again when something big comes out. It's like, I need to know what Junaid thinks about this. So I will probably have you back on the podcast to discuss those things. But thanks so much for sharing your incredible insight.
Well, you're very kind. You made, I don't normally do this, but you've made this super easy.
Well, I appreciate it. Thank you for doing it, because I think it was really important. And, when we met in London and I was chatting with you, I was like, oh, Junaid, he's really fascinating person. So I was very excited to have you on. So finally, we were able to make this happen.
Well, you're very kind. Thank you very much.